Hi everyone, good afternoon and good morning. Welcome to this AMS Automotive Evolution live stream looking at modular production and flexible automation. I'm Christopher Ludwig, Editor-in-Chief here, and I'll be the host of our session today, together with some great experts from the industry to talk about opportunities and changes in technology, whom I'll introduce to you shortly. But why are we here? Well, as all of you know, the automotive industry is increasing production of electric vehicles and battery, and doing so in large part alongside other vehicles in brownfield facilities in many cases, producing multiple powertrains and vehicle types on the same line. That, of course, requires growing amounts of flexibility, but what's more, technology, product development, the time cycles, the product cycles and development cycles are certainly compressed and changing much quicker than we've seen previously, which requires a whole lot more room for flexibility and change on the shop floor across plants, and in terms of the tooling and equipment that are used. And at the same time, the new types of automation, from AMRs to end effectors to new types of linear motion, are creating a lot more opportunity to increase this flexibility. And that's what we're really excited to talk about today with our expert, and of course to hear from you. And throughout this live stream, we really want to encourage you to ask questions, which we will be putting to our audience throughout. So again, we'll talk for the next hour or so on making it modular, production's flexible future. I will bring them on shortly, but I will be joined by four experts in the field. Lauren Sanchez, who's a director of Automotive at Linear Motion and Actuation Specialist Evolix, also with Christian Leitner, who's a business leader for future mobility at Automation and Technology Specialist Rockwell Automation. We'll also be joined by Sungwon Lee, who leads global product development for flexible solutions at Evolix and is the managing director in South Korea for the company. And joining me as well as ever, my partner in crime here at AMS is Nick Holt, who's our editor, and certainly will bring a lot more perspective on things which we see at AMS happening across the industry in this space. So just a little bit more about the why. As mentioned, the variation, driving need for flexible production and automation, multiple powertrain types, vehicle types in the same facility, often on the same line, more frequent updates, requiring more flexibility, as well as integrating these new technologies and batteries and module assembly into brownfields. Not that we won't talk about greenfield as well, but it's really key to be able to do this, of course, in existing facilities. And we see the opportunities that startups and greenfields are taking to optimize some of the space, which we're going to touch upon as well. And clearly the rise of battery cell production gigafactories is also requiring a lot more flexibility in producing fast changing technology. There's a lot of opportunity in the marketplace in terms of the technology which is allowing for this. As I mentioned, AMRs and AGVs with autonomous logistics flows, providing opportunity for cellular-based robotics, where production planning and workflows can be optimized by availability and priority, more flexible tools that can supplement or enhance, adapt existing robots and tooling that allow for more change, and certainly greater use of connectivity, software, data analytics across production to develop more predictive and responsive production. And last but not least, talking about different kinds of automation, assisted automation, cobots, and the role that they can play in production, both now and in future, perhaps in areas that typically have had less automation in the past, such as final inspection. Today's live stream is sponsored by Evolix and Rockwell Automation, and plenty more information you can find out about these companies as well on the AMS website, and of course by visiting them and learning more about opportunities in flexible automation. Before I kick off and bring in our great panel, just wanted to quickly highlight the continuation of this live stream series in a few weeks' time with our signature event for the first part of the year, the AMS Automotive Evolution Summit, 17th and 19th of May. We're going to be talking in a lot of detail with many different manufacturers and specialists across changing EV and battery production, flexible automation, sustainability in production, digitalization, and a whole lot more. There's a small sampling of the 30 or so different speakers who are joining us during the panel, during the summit, those 3 days, from Peter Weber at BMW leading plant Munich to the head of electrification production for ZF, the COO of Polestar, Dennis Nobilis, head of battery production for Scania, and many, many more. You can see a few there. Please do consider joining us. This event is free for OEM and tier 1 manufacturers, but we have also a special offer for everyone else, 50% off with a code which is being dropped into the chat as we speak by our team. You just enter that link and you get 50% off the registration price, and you just add in the code which you'll see there, and you are very welcome to join us. I hope you will. There's a lot to talk about those coming days, but for now I'd like to get to the meat of our session. Sorry, just need to stop sharing my screen. There we go. And I want to bring in our expert panel as mentioned. So very pleased to welcome to join us Christian Leitner, as mentioned earlier, business leader for future mobility at Rockwell Automation. Christian, very good to have you here.
Hello, nice to meet you.
You as well. Laurent Sanchez from Evolix, Director of Automotive. Good to have you. Good to see you, Laurent.
Yes, hi everybody. Thank you.
And joining us from Korea, Song-Won Lee, who, as mentioned, is leading development for flexible solutions and is MD of the company in the region. Good to have you here, Song-Won.
Hello. Yeah, nice to meet you.
And as mentioned as well, Nick Holt, who leads our editorial here at AMS, our resident automotive automation and production expert, Nick Holt.
Thanks, Chris.
Great. Okay, everyone. So, we'll want to jump into some questions and leave plenty of scope for our audience to feed in. But I really just wanted to start from hearing from our panelists about their definition, your definition, first of all, of modular production as it exists in the industry today, versus perhaps what you see the potential for this sort of flexible approach over the coming years. How different that may look from current assembly, and perhaps you can just expand a little bit about what you're working on in these areas too. I'm going to start with you on that, Laurent.
Thank you, Christopher. From our side, I would say from an Evolix perspective, what we have seen the evolution along the past few years is mainly on the body in white part of the automotive assembly, where we have seen a move coming from fixed tooling towards a move going to a more flexible way to handle the tooling. So flexible tooling, so different type of applications such as car transfer unit, NC locators, and effector, hand of arm tooling, and so on. So I would say back in 2010, we started to have numerous projects in this area trying to make the tooling more flexible. And now it's really becoming a strong interest from most of the car makers in most of the areas.
Great. Christian, what would you add from Rockwell's side?
Yeah, I believe, as you already said in the introduction, so I take care of everything related to electric vehicles and battery, right? And what we see, or what I see in the market, is basically latest since the rise of the electric vehicles, most of the automotive manufacturers are shifting the production now to a more modular layout, right, to cope with the very challenging and dynamic market conditions, right? And I believe it's not just the production that is becoming more modular, right? It already starts with product design. It's modular software that is implemented. It's modular operations management systems, and it even goes further to modular supply chains, right? So everything is becoming modular throughout the entire value chain. And I think if you look at some of those emerging EV startup companies, they've already shown what is possible, right? I mean, they are pushing the envelope here in terms of innovations. They are setting up microfactories just now, very close to the customer with built-for-purpose products, everything organized in cells, highly automated and standardized, fully digitized, connected wirelessly with HEVs, AMRs, and so on, right? So I think that becoming more flexible and also becoming more modular. I mean, all those things are currently happening right now, right? Not only with EVs, of course, but also with the traditional vehicle manufacturers. And yeah, so I'm also not saying that let's say that the same approach is the only way of becoming more modular and flexible, right, in the industry.
So already some interesting range there, and as Laurent kind of highlighted, we have in effect the sort of technology which we are seeing implemented perhaps in, let's call them traditional plants for lack of a better word, to enhance flexibility and modularity there. But as Christian said, I mean, we're seeing some pretty interesting, slightly more radical approaches from some new players as well. Sort of what's sort of jumping out to you in terms of modular production?
Nowadays, car makers, they want to really go to more flexible things because now everybody just say smart and also IoT, then also is linked to the production line as well. So now it's really time to change the production line. And actually, for the electric vehicle, anyway, they have to change the full line. So they are now starting to really invest a lot of like a flexible and more modular concept for the production line, smart and smaller, even the like on the building. So it's many things now is really innovated. So that's how things is bring a lot of the benefit, also a lot of technology. In the past, they mostly use very fixture things, also pneumatic things, but now it's really go to the electric side without any energy consumptions. So that's really right direction, and also is going forward there.
So quite important, the aspects that IoT and connectivity will play. That's a good point that we're definitely going to go into a bit more detail a bit later in the discussion. Why don't we round that out, Nick, with anything you'd add from what we've seen at AMS?
Yeah, Chris. I mean, modular production is not new in a way. If we look at parts of the, it's been around for quite a long time. We still see it like body shop mentioned there by Laurent. You see sub-assembly stations. Powertrains is a very good example of it, really. All the machining operations are done in a modular way. I think what's the big change that we're seeing is not that those are necessarily in themselves being made redundant or being more of. It's what the other panelists have alluded to is the fact that it's becoming a lot smarter. It's the fact that those production cells can now be made more flexible and can multitask to a much greater extent than was ever possible in previous years. And as again, panelists have alluded to this, there are big changes now. So the way that car makers are approaching there and investing in making big investments in their production operations, they're rethinking about how they do it. And now they have essentially the digital tools, if you like, to make those robot cells far more smarter and able to do not just a different task, but to be able to prioritize and to be able to shift capacity around depending on how it needs to be. And there are lots of opportunities with modular as well. We know, I mean, the latest modular cells, they're relatively still small scale, but they can be scaled. So you can add more in, you can bring them online, take them offline as needed. And that level of control is really making a big change. We see it across tier suppliers, a good example where there's a lot of modular operations, but with the larger car makers, we know that companies like Audi have got their sort of innovation lab. They've been pushing their Automotive Initiative 2025, where they're using a lot of digital tools to enhance their production operations and look at it from a modular point of view in the way they operate. And I know that Mercedes implemented this at Bremen for the new C-Class in their body shop. So they changed the way they did it. It was a new body shop or new sections to it, and it was, the functions themselves were not new, but the way that the functions went across each of the cells was, and the way that they operated and can change that was really key. And that is essentially in mass production. And if we, I was looking to the past a little bit with this, and back in 2017, Honda launched the ARC line, where that was classed as cellular production, where the workforce actually stayed with the car and the whole workforce moved on a conveyor belt essentially around picking up the parts. But that was kind of an early sort of stage of that. But we're definitely seeing a lot of opportunities being opened up with the with modular production, and it's a necessity now, because the diversity of powertrain is a very good example of where the OEMs need to be able to make a number of different kind of units, and they need to do it cost effectively. So they need to be able to flex depending on demand numbers, location, parts and operations. And something like the powertrain, where there are a lot of operations involved in the whole process, that kind of flexibility is really key.
Some great examples and observations there, Nick, and obviously you can find out more about many of the things Nick referred to on the AMS website there. What you gave was some good, I think, almost like lighthouse examples, but also things which are in serial production. I wanted to ask the panel if you're seeing, again, sort of, are you seeing more examples, if you like, in the pilot level, or really concrete implementation? And I know we have a big range of how we can define this in terms of what we're talking about. But again, I just wanted to get a bit sense from the others of what really interesting examples you might see. I want to start with you, Christian.
So yeah, I mean, I can again speak about EV startup companies definitely that are already embracing a lot of new technologies, right? And as I outlined before, it's not just about the production process itself. It already starts with the product that is becoming highly modular, right? So, and the product itself then drives the entire manufacturing process that comes after that, right? And then there is of course also other, let's say, newer technologies. Everything related to manufacturing software that is supporting that development. So it's in order to get more visibility into your operations, there is newer innovations, let's say, cloud-based solutions that really help you basically to further get ahead to those things.
Great. So more interesting examples of drivers. Laurent or Songwon, would you add anything to that?
Yeah, I think what we can see, whether it is with a new player, I mean, the powertrain, different type of powertrain is a good example of a variance that you can see in a car production line today. But it's not only about the powertrain; it's also about the type of vehicles you want to drive. For example, if you have a sport utility vehicles, or if you have a sedan, or if you have a coupe or a sports wagon, and now these are just examples to demonstrate, I would say, the complexity of running the production of all those different type of model on the same line. A traditional conventional line can handle 1, 2 type of vehicles, eventually 3. Some car makers today are talking to 5, even 12 different type of car models. So I think the variance that we see today in the way that the automotive cars are manufactured and proposed to the market, and the end user are using the cars, is showing a so high diversity that the need to transform your production in a more flexible and capable production line in order to accommodate with this variance in a competitive way, because you can accommodate the variance, but this is bringing your cost up. So how do you still accommodate this variance and remain keep a competitive cost base? So that I think is what is behind as well. There is of course a question of competitivity behind this, and we have seen a couple of examples again on the body in white. If we take the tooling of, for example, the end effector, or we can call it also the end of arm tooling, I would say. There we have really seen an evolution. We started with some pilot, I would say 10 years ago, and now we see this running in series in numerous plants with this ability, with a flexible end effector, for instance, to be able to cope with different parts. For example, different doors, different side framing of the car in the body in white. So that I think is something that is bringing a lot of value to the car maker.
Absolutely. I think we've touched upon quite a few of the drivers now and the requirements for why this is coming from, the variation, as we've alluded to, EV battery, also the connectivity and IoT. From the panel's point of view, is there variation in the sort of speed of flexibility that we see in different regions or different players kind of in the market? Christian, I might start with you on that one.
Well, variations in the market. I think, you know, especially, and I can talk about the EV side as well. I mean, I think that the shift to the electrification is really forcing the industry to think outside the box, right? To keep up with the huge demand in the future, especially on the battery side as well, right? And I honestly believe that again, startups are playing a huge role in this transformation, since they are really challenging all existing production methods and technologies here. So yeah, I would not see that, you know, certain parties are further ahead others, or that there is a strong difference between different regions, etc. Of course, we see a trend that there is more startups emerging from North America compared to Europe or Asia maybe. But apart from that, I would say there is not too many differences here.
Mm. So clearly, in some cases, as you kind of said right at the beginning, there are some startups which are clearly looking to break a mold here, but the drivers are pushing in every direction. Laurent or Sang-Won, is that where you've landed on this, or is there anything else you would add to that?
I'm actually working in the South Korea and also close to the many Asian country and also car makers there. Actually, as you know, mostly a flexible tooling system is starting from the Japan. So they try to allow the different idea and also adapt their like new equipment and flexible tooling by robot, industrial robot and others. After that, also South Korea is starting that since 10 years ago already, and they now is mostly when they build up new factories, they're almost they're just using flexible tooling, because they don't know in the future which kind of model and size they will produce in the factory. So they mostly, if they can do, they as much as possible they can produce make the like flexible like tooling system. After that, I also now is in the past a little bit European market and US. There are still produce same size or same car models in the one line, but now they are now think about more flexible things in the beeper. In the past, now it's much better than beeper. So such kind of things is coming. Their inquiry and request, or they want to check the market. And they also one of the big topic is that they now have to produce electric vehicle anyway. So that's also a very important thing. They need to change anyway their lines. So they are now really think about the flexible production line in their factory.
Yeah. Yes, and I would, if I could add up something to what Sang-Won just mentioned. I think we indeed saw this coming, especially in the body in white, starting a little bit in Asia. But I mean, as mentioned by Nick before, we've seen the flexibility as a discussion for a couple of years. But definitely, this push with electric vehicle is having a lot of consequences, and I think. Linked to this, there are two consequences, because of course you can, you know, when you build a greenfield factory, okay, it's a huge amount of investment that has to be carried on, but you start from scratch, so you can really design the way you want to design your factory, the best layout, and that is one part of the game where we can really bring flexibility from the start. But one of the challenges that we've seen as well is because, you know, not everything will be greenfield factory. It's going to be also some brownfield plants. So we need to upgrade a current plant. And this is bringing an additional challenge, because how do you bring a brownfield plant more flexible with some constraint? Because you will have some constraint when you have a brownfield plant. And that has been a big area of discussion linked to flexibility, because in order to do that, you need to free space. So you need to make sure that you can gain space and save footprint, surface footprint in your factory. Okay, and if you don't make the move towards more flexible tooling, for instance, then you'll have some challenges to do this space saving. So I think the footprint part on the brownfield is a key point as well, that is driving flexibility, because that is helping car makers to save space and to accommodate in the same line more vehicles, then they can really gain space. So of course, cost linked to that. A good example is, you know, if you have a fixed tooling, and you have a fixed tooling for a sedan and for a sport utility vehicle, okay, then it means you have your robot cells and you have two different types of tooling, and the robot has to take one tooling, then put it back, and then when the vehicle changes, he is putting another type of tooling. When if you have a flexible tooling, you only have one tooling. Okay, so you have saved the space for one tooling. So you can imagine if it's not one tooling, but if it's 5 different vehicles and 5 tooling that you save, then it's a huge saving that you are doing. So that, I think the brownfield plant linked to the footprint in terms of saving footprint is, as what we see from the side, is that is a key enabler for flexibility.
I think that's a really interesting point, and I wonder, Christian, are you seeing similar examples?
Yeah, so I couldn't agree more with Lau, and I believe, you know, in terms of brownfields, it's of course always a challenge. If you have a legacy system, it's going to be always very difficult, basically, to really create a full modular production, right, and you know, achieve that flexibility that you might look for, right. So if you have the beauty of starting with a greenfield, you can do it right from the beginning on, right. So you just with one network and you know, just with one single platform, and then you know, grow it from there, right. So that's, but of course, as we know, that's not always possible. There is a lot of brownfields out there, but that does not mean that it completely prevents of you know, creating a more modular, flexible production. And this is also what we're seeing that a lot of customers are doing now. There is technologies available to simulate and emulate changes in your production even before you even touch any of the physical parts, right. I'm talking about a digital twin, for example, that can help you simulate and emulate some of those things before you even do something, right. And the next thing is, of course, and you are also experts in that, linear motion technology can also help you to significantly reduce the footprint of the plant, because space is expensive, right. And this is also bringing some limitations on that one. And then, of course, there is other technologies like AMRs, HEVs, etc., cobots, etc., that can help you to you know, increase the flexibility within a brownfield plant. So it's not necessarily a showstopper, but of course it's way more complex, and a careful assessment is needed, because you know, if you do not want to compromise your existing production, you will have to be extremely cautious about that one. And you know, I think it's even, we're also seeing that most of the times, once you have a mix of different platforms, let's say typically internal combustion engine, and then a new development for an electric vehicle platform, most of the times this is completely separated now. So because I think it's there is a lot of limitations, a lot of risk if you mix those two things. It's really better, even within a brownfield, to you know, differentiate or make different segments, to at least try to start from an area perspective from scratch on to do it right.
There's a really fantastic, interesting points on I think the sort of opportunities to save space, the technologies involved that can help implement this in a brownfield as well. I want to get to some of those technologies, but first, Nick, maybe anything you'd want to add to that. I mean, unfortunately, the pandemic has limited the number of plants you've been able to walk around and get a bird's eye view in. Hopefully that's changing soon. But you know, in terms of what you're seeing in this kind of race to save space and optimize brownfields, what are you seeing in the market?
Well, I mean, it's interesting the comments from the panelists, because we're seeing almost two, not wholly, but different tracks here. So where it's, I mean, Christian was right there. Cars, some of the new cars, some of the startups are building cars with a very particular approach to the manufacturing operations. And I think I'm trying to think off the top of my head. There's a company called Arrival, which makes kind of light commercial vehicles. Now they cut all of their own panels. They're assembled in an automated way, bonded together. And that's very much indicative of that, or a good example of that kind of new approach with some of the new guys. And as Laurent mentioned there, the legacy plants, if you want to call them that, the bigger car makers, they do need this flexibility, and Laurent highlighted there the challenges in the body shop, and that's kind of another driver, and perhaps a slightly different approach, in the sense they're not trying to reimagine how they're making cars, but they're trying to build in flexibility into this modular idea into their existing plants where it's required. And it shows kind of two sort of parallel tracks, but ultimately the the drivers are similar, and I think the technologies that are facilitating it are the same. Essentially, is this new technology, the whether it be the hardware that Laurent and so on were talking about, and also the sort of digital IoT, the much smarter operation of that hardware as well. So you've got that combination. But it's actually interesting listening to the panelists, because they kind of highlighted those almost two layers with the startups and the greenfields, as you mentioned there, and the brownfields. The thing as well with the flexibility and the modular approach, and I'm sure they may want to comment on this, but the opportunity to reduce the footprint of the manufacturing operations by being able to have a cell or a production sub-assembly area multitask must be very, very attractive to the bigger car makers, especially as Laurent mentioned there, and Chris and I, we've been to quite a few of the plants, well-established plants, and some of them are in city centres. They are highly constrained in terms of what they can do when they're looking to upgrade or revamp. So opportunities are there massively, and almost two different kind of drivers pushing them along. It'll be interesting to see how much convergence there is eventually with the new startups and the existing manufacturers. Obviously, some of the new startups are using contract manufacturers to produce their cars, who, like the bigger car manufacturers, have very well established linear production line operations. So it's very interesting to see how all this is going to kind of play out. But yeah, the sort of greenfield brownfield question, I'm sure these guys are seeing more from different customers as to how much that's differing.
Nicky, if I may add to that one, so you mentioned Arrival as an example here, and I honestly believe it's not just differentiating between greenfield and brownfield, it's also differentiating between the product, because Arrival is very special, as we know. They built for purpose products, vehicles, vans and buses, with, let's say, lower quantities as usual in the automotive industry. So you cannot really compare what they do in terms of product and quantities with what a Volkswagen or a Ford or any other big company does. And I believe also that needs to be taken into consideration. Everything that Arrival has done is amazing, and it's pushing the envelope. It's super innovative. There is not a single conveyor in their plants, so they have really made the perfect microfactory, in my opinion. But and they're also using new materials and completely new technologies, lightweight materials, like fiber materials, etc. Right? But on the other hand, I mean, they have way more, let's say, lower quantities and things like this. And I don't think that this necessarily, could be replicated to a big car maker that makes, millions of cars every year. So I think flexibility for Arrival looks different in modularity compared to someone that is, a more traditional car maker with a standard, let's say, paint body shop and assembly line, right? So that's also something. But still, I believe there is a lot of potential also for those existing big traditional brownfield companies, to increase the flexibility within their existing plants.
Yeah, absolutely. And I think we've been talking there on some of those differences with greenfield and brownfield. I thought maybe this is a good time to go into a little more detail on some of the technology enablers, if you like. We've alluded to a few of them, but maybe we can go in a little more detail in one or two areas from each of the panelists. I want to start maybe with Laurent and with Yves on that. In particular, kind of things related to, I would say, more brownfields. You alluded to the end effector previously. Are there other examples you'd give in terms of what's really happening in terms of bringing in more of that flexibility to accommodate these new products and create that space opportunities that you talked about? Maybe I'll go to you first, Laurent.
Yeah, I think we have a number of cases that we have experienced in the past and that we are working on. So we mentioned the end effector, which is one which is very important in the body shop. So we had quite some area on that. But there is also what is so it has different name, but it's more linked to the bottom of a car chassis. When you manage a car chassis, is to have a flexibility that we call the car transfer unit. So basically, you can position X, Y, Z, the bottom of a car in a different location. So if you have a different parts, then you are able to quickly adapt and repurpose the tooling in order to accommodate very quickly in a few seconds to reprogram and readapt to the vehicle that is coming in. So CAD transfer unit is one we've seen. We can see it also on the geoset type of application, which is more like a fixed fixture, but then we bring some modularity on the fixture, so that means that a fixture can move. I think if we have some video, we can maybe show that will maybe talk better here. So we have been there is, and I'm sure there is much more to come as well. We have seen some of the final inspection. Maybe we'll come back to that later on, linked to the cobots as well. So I think there are quite a number of areas that can become flexible. And I would say if I look at the car maker and what is what we need to bring, we need to make the life easier, I would say, to some extent, because it's quite a complex change they are going through. You know, they have to manage the mobility with the autonomous vehicle, they have to manage the battery production. So a lot of investment are connected to new technology that the car maker has to develop. Somehow the flexible tooling is technology that are existing on the market, but that needs to be adapted in order to fit in the plant. And this is where a company such as Evolix, we try to bring this engineering capability to make the implementation faster here. So I would say that that's something that also is needed here, is that there is a need of co-engineering, co-creation together. There is, if you cannot be successful on the flexible part if you don't really get close to the application and really understand the needs. Otherwise, you go and you propose something that is a bit standard, but the problem is that it doesn't fit the need, especially if you talk to brownfield plant where you need to adapt to the local constraint. So from our point of view, it's a lot about co-engineering with a car maker in order to have a fast and efficient implementation.
Great, and yes, I do have an example here we can show. It's a short video, so we can put some of that into action, and we'll just show that to the audience briefly, and we can come back to it. So we'll run that now. Okay, so there was a bit of an action there. Before we go to Christian for some examples, maybe Laurence, I want just tell us a little bit about what we just saw there. I mean, that was the car transfer unit, I believe, with some end effector there too. But maybe if you just want to explain a little bit more about what we saw. Yeah, Sagwan, can you explain what you've seen? What?
Yeah, so that video is just for showing flexible end effector. And then we use linear module with servo drivers over there. Then we just can change the clamping unit to the different position for the clamping the other like part. So this is just one part, but we can change the clamping point and then take the part at the different position. So we only show 3 linear modules on there, but we can very flexible to attach another one and also the other axis. So then it's more flexible than others. So it means many different parts can take by just one gripper, flexible grippers.
Yeah, I would say this is really an example. So this case is a 3-axis case that we've done in Asia, but we have been to 5-axis, 6-axis, and we can go up to 7-axis depending on the size of the parts that needs to be managed. But you can really see here, if you would have an end effector with a fixed position, basically, you will have to change all the time you have different parts. So the saving here is, you know, in a few seconds you adapt to the new part, which would have taken you probably a human intervention before, because for example, traditional end effector with manual positioning. So you have to stop a robot, somebody goes in the robot, change the position manually, then close the robot and you restart the robot. But you know, when you go in an automotive plant, you have this is all large robot. It's not cobots. It's not in it. So they are in cells. So you need to stop the cell, open the cell. So it's a lot of work to reset the unit, if I may say so. So with this, you will immediately see the benefit of a flexible tooling.
And also just side of the part, and if we think about the different position in the future, we can provide different like strokes, and then just if you programmed a certain position, then it can be changed for the next one. So normally the size of the part has some limitations, so we can clamp the other part and in the like that range of the strokes. So that's very important for the future. And once car maker invests such kind of flexible tooling, they can use continuously more than 5 or 10 years. So first investment is a little bit higher than a fixture system, but in the future, after saving all of the things and using for the different size, then they can save all of the money and also time. And if the production line has different models, then they don't need, as Ro mentioned, they don't need any like change the tooling. Just within very short time, they can change the position, then immediately start for the next different size. So it's very efficient and very reduce the tech time. Also, cost point of view is very saving a lot.
Yeah. Definitely, I think that is an analysis we've made. We had one case in the US with a customer, and we've been through this trying to understand the return on investment and trying to calculate the return on investment. And that's the main one of the biggest saving is coming from the time to reset the assembly cell from one car to another. Because that's normally, if you have a fixed fixture, you need to design this fixed fixture, you need to assemble it, and then you need to install and commission. It's I think I remember we made this analysis. We said 85% of time saving in terms of reset of the cell. So it's quite significant for the car maker. Quite significant.
Absolutely. So great examples there in action. Christian, I wonder if I can turn to you. I mean, you in particular in your role have a lot of oversight and responsibility for the EV and battery production side. So in particular, perhaps as it relates to battery cell production, are there specific technologies you would highlight there, which are really playing an enhanced and key role?
I would say there is not too big difference between the classical vehicle manufacturing and the battery, but nevertheless, I'd like to take a little more holistic approach. And as I also outlined at the beginning of the session, for me, modular production really starts with modular design and engineering tools, right? And that is, for example, using modular software platform to speed up the entire design phase, right? So you can automatically or quickly generate controller code. You can create your standardized HMI screens and stuff like this, right? This will also help you to be quicker to the market and in general be more flexible. Then, as I also explained before, using a digital twin software is also very helpful, you know, to validate and test designs upfront, do operator trainings, and even do complete virtual commissioning, right? So that's another thing I believe that can help tremendously in becoming, let's say, more flexible. During operation, once the design phase is completed, you can use even a modular MES system. So that means a modular MES system basically is comprised of core functionalities or templates, and you just pick what you need, right? You don't need to go to a fully blown MES system, manufacturing execution system. You just pick what you need, and depending on, you know, where you actually develop in 1 or 2 or 3 years, you can then just, you know, expand from there, right? Or you can also scale down if you see that, you know, some of those functionalities are not needed anymore. And if you use cloud-based software as a service on top of that, so that means if you run your MES system, or if you run your, I don't know, CMMS in a cloud, that even adds more flexibility, in my opinion, because you don't need to worry about the infrastructure. You can scale much quicker. Because in a traditional on-premise solution, you will have to do everything, right? You will have to install. The implementation takes quite a lot of time. It's quite cost intensive as well. But if you really start with a product that is already there in the cloud and you just utilize what you need, I mean that's a great benefit, right? And that can really speed up a lot of processes as well. In terms of intralogistics, and that is again very valid for greenfields and brownfields. I'm talking about the traditional conveyor systems, right? That are sometimes rather cumbersome to maintain, etc. I mean, this could be very well replaced by linear motion solution, right? There is technologies available today, and also Rockwell has something that is called independent cart technology, and this it's basically a smart or intelligent conveyor system, right? That replaces, you know, those traditional conveyors. And the advantages are quite obvious. So with the linear motion technology, you have way higher speeds. You can increase your throughput dramatically. You can carry more weight. So that means you can basically even move entire vehicles if you want, right? You have a built-in track and trace functionality, which is also very important for a lot of manufacturers. You can move bi-directional. With a conveyor, you can only move in one direction, right? But if you have a linear motion technology, you can go in both directions, and so on. So, and at the end of the day, this will lead to less space needed on the production floor, and then also, of course, lead to, let's say, less cost in the long run.
Excellent, and I think we actually have a bit of an example we could just show as well here. So I'm gonna likewise play that short video.
Slow them down and regroup them, and you can carry very light things like just a simple cell, one entire pack that goes up to 1 ton, one entire vehicle if you want, right? So it's a highly standardized system. Think about Lego bricks that you put together, so you can easily extend or the system as needed, or just change it if you feel that you need more stations, or if you do something else. So that's basically one of the main advantages. And of course, in terms of throughput, I believe this is also a system where nothing comes close with a traditional conveyor, since you can go with much higher speeds and still handle your products with a high care, because you can de-accelerate and accelerate very softly. So this is just one of the main advantages of such a system that could be implemented everywhere.
Great, another great example there, and illustrating well what we were talking about. I want to come back to a point Laurent made earlier on the co-creation, co-design, and then of course, Christian, you were talking about the tools available with digital simulation and twins, which perhaps can enhance and speed this up. I mean, from the panel's point of view, clearly that's something that could benefit this push to flexible production. Is there more of it starting to happen? Are you working more and in different ways with your customers, with OEMs and manufacturers to do just that? Or is it in fact there's still perhaps room to integrate this planning earlier? I'll start first with Laurent and someone on that.
Yeah, I would say from what I've seen is that it's coming suddenly. So I have seen two cases. You sometimes have an engineering team which are convinced since very long about the need to become flexible. So we've been discussing with this company and with this engineering team for a while, and then we do some prototyping, and we go into a test cell, for example, at the beginning in the R&D, more in the manufacturing engineering process department usually, and then it goes to a real line where we make like a small cell, and then we go to the final. So I think it goes in different speed from what we have been able to see. We also seen some project recently where, you know, the push is so high to get it flexible that, you know, we need just to get it. So suddenly you have an engineering team that is coming to you with a lot of requests, with not having a sense of how they can make this tooling more flexible. So they really expect us to come and bring some expertise there. And for us, it's a good opportunity to bring our expertise. But of course, in front, we need to understand also the need very clearly. So that's where co-engineering goes into a picture, so that we can be very efficient. So this is something that we also do in order to work with the team, is that we need to really understand well what are the requirements from the customer, and what is the cell, what is the part, really understand well the application. So, but we have seen very different type of approach on this market. Sometimes it goes in more on the R&D side. Sometimes it goes almost straight in a real line because the push is very high. So I think there is not one single pattern, I would say. And there is definitely not one size fits all. That's for sure. What we do on our side is we reuse our modules. So we have a kind of modular base of component so that we can make our product development and our design by reusing the parts, reusing some parts. But at the end of the day, it's going to be something that will be adapted to the application of the customer.
Absolutely. Christian, would you add anything to that?
Yeah, I couldn't agree more. So, I mean, also at Rockwool, we care a lot about partnerships to really, you know, co-create solutions. I think that's within our DNA. And at the end of the day, in order to really be successful, it's all about collaborating closely and, you know, creating those partnerships in order to you know, gain those, let's say, synergy effects right out of this. And for us, it's really important that we get involved very, very early in the process, right? I mean, and early in the process means, I mean, we are industrial automation and information software company, right? And most of the time, you know, people think, okay, it's sufficient if you get involved after the let's say bid specs for the line builders are out or something like this, right? But in fact, right, we would like to get involved very, very early at the pre-engineering or, you know, feasibility studies, right? Because I think that is the right time where we can bring our expertise and also even help, let's say, drafting some of those specifications, right? Because in order to be really successful with a highly flexible plant, the core platform needs to be done right, and there is already a lot of knowledge needed. And this is actually where we come in and help customers, you know, in doing that. And we also have internal and external consultants that we work with that help customers with the journey. Because also, as Lauren said, there is no solution that fits everybody, right? Every client is unique. I would say on the battery side, the R&D portion is still very much needed because the technology in general is still evolving, right? I mean, we have the lithium-ion battery now. There is other technologies that are currently in development, but nevertheless, everybody needs to make sure that they test the cell chemistries before they go into mass production. That might be a little bit different on the vehicle side, because that's a way more mature market. And I agree with Lauren also here that it might also be possible to skip some of those development R&D, let's say, phases and going directly into mass production type of manufacturing by using, you know, tools, as I said before, digital twins and other, let's say, virtual tools to support that, to be sure that you know, implement the right.
Nick, I feel this has become one of the really core topics that we're often discussing with manufacturers on how they're trying to optimize the planning earlier, using different digital tools, twins, but also integrating the suppliers earlier. Right? Is that sort of something you've seen as a shift in recent years?
Yeah, and I mean, it's interesting listening to the guys. It's a trend we're seeing across. Certainly, we saw it in sort of the tier supply area, where the car makers, because of the transition to newer technologies, to different architectures, powertrains, etc., bringing in new competencies and skills, they've been leaning a lot more heavily on their suppliers to supply solutions, not just turn up with a product. Not to say there wasn't always an involvement, but now there's a much deeper kind of working relationship in that respect. And Laurent touched upon it there, and Christian, in the sense that being involved much earlier in the process, especially if it was designing a line or it's around a new platform or a new component, is much more important to optimize that production process now. And also, if car makers want that flexibility, they can't just say, here it is, go away and find a solution. There has to be that kind of collaboration, and we are seeing that, and it's really interesting. And just going back to the point Christian made a bit earlier about Arrival, that mindset of kind of designing a vehicle with production almost foremost in that process. That's not to say that cars aren't designed to be manufactured, but quite often not to the extent you might imagine. And I think the Arrival example, as Christian pointed out, is a very key thing there. And I know interestingly talking to a number of equipment suppliers across the whole production operation, one of the interesting things I hear them say is, if we could speak to the design team, we would say, and Laurent and someone might be able to comment on this, especially like handling bodies and things, the way the body is designed for a structural purpose to fit a powertrain. It's not always designed with handling in mind, and hence the guys are creating these kind of flexible end effector tools. And if you look at the shape of a floor plan, I mean, they look pretty flat, especially now they're going towards battery, but they're still a complex shape. And it's not a case of just picking it up and putting it somewhere. There's a degree of precision that's needed, which is escalating now if you're automating these things. So I remember talking to some of the equipment guys going, if we were actually involved with the car designers, we could say, can you make it do X so that it will enhance your production flow because of, whether it be materials or joining or whatever it might be. So there is this greater sense of being involved, greater perception in the upstream side of the vehicle design and manufacture. And again, going back to Christy, there may be, as this evolution of new vehicles comes along, there may be more of that. We're seeing that, and obviously the panel here can testify that they are seeing a much, I'm sure they're being asked for more, the demand from their clients and customers must be escalating now, because they're not just coming with a list of, we've got this, can you fix this? There'll be a list of things that are contingent around, and then we get back to the topic around this flexibility. Flexibility in body shop, always been a challenge, always been a big challenge. So all of these things are kind of coming together, and interestingly, not no pun intended, but in respect of that, the suppliers, i.e. the guys we've got here on the panel, have to be very flexible too in their approach and what they're doing, because as I said, there's not a one size fits all anymore. It's not like going to Ford, General Motors, it's a big long linear production line, largely all the same. They're all different, and they're all coming from battery production is a great example. They're all coming at this from slightly different angles. So it might be a different battery cell format, it might be a different battery box or location. You've got then mixed of hybrid vehicles and platforms. So there's a whole raft of variation in there that is possibly unseen outside of the manufacturing operation, that from an operational point of view has to be dealt with the equipment, the software, the process, the materials. And again, that's again, if you want to pick on the topic of flexibility, that's again a big part of that, I think, as we go forward.
I think you really get a point here, and I like the approach you had, saying that we link to the design, because I would say we've seen that is that where do you stop, the modularity? Because at some point, you can make it modular, but you cannot make it to an infinite number of positions. So of course there is a limit, and where do you put the cursor is something that we often have to discuss with the customer, because of course we all would like to have an extreme very modular, but then of course there is constraint linked to the weight, for instance, links to the cost and some elements. So I think there is still, if it's flexible and modular, there is of course a limit to be defined, and this has to be defined together with the customer in order that we have something that fits the requirement. But it's so often that it happens in all company. I would say that you design a car, and then you go, okay, we need to produce this car. Yes, but how am I going to produce that? I need to change my tooling. So I think it's also the connection. This flexible tooling is also probably helping in the way that you can industrialize new model as well. Because when you industrialize a model, you define new models, you try to take all the constraints in terms of industrialization, of course, but you cannot, anticipate all the constraints linked to industrialization. So, and then you discover things when they are coming. Even if with a software tool, digital twin, you can anticipate a lot of things, still you will get surprise on the way. So if your tooling is flexible, you probably be able to cope with much more surprise than you would have done with a non-flexible tooling or system. So I think that's clearly something that we've seen. And I would say that we talk a lot about, variants, number of vehicles, type of vehicle, and so on. But when talking about electrification, I think one thing that we see as well a lot is that this has a tremendous consequence in terms of the material used to produce a car. And this is also bringing like different areas of flexibility, because you need to, before you had, one type of steel coming and then a little bit of aluminium, but not much. But now you have to join aluminium and dissimilar material together. You have high strength steel. So also the type of operation and process in the body shop needs to be flexible. So it's not only the, the tooling and so on, it's also the way to manage different type of material together. If you want to join high strength steel, it's very different in terms of welding, for instance, as it is traditional steel. So if you have two types of those steels, how do you manage this in your cell with your tooling and with your robot? So I think it's really something really high now in the agenda.
Fantastic. I know we're running a bit late on time. We've got some, obviously covering some great ground here. I might go just a little bit longer because I'm selfish like that. And I like to take advantage when I have experts on the line. But we're maybe just a few questions more. But Christian, one of the points I wanted to go back to, you referred earlier, of course, to the sort of opportunities, of course, in software and modular MES. And inevitably, of course, we do see, I guess, a huge confluence of different systems on the shop floor, from cloud to microsystems to various different systems by robots. Do you see that in any way as a challenge or a barrier, or at least something to overcome, at least in kind of moving to the next stage of what we're talking about here? Because clearly we do have a mix of legacy, new, and etc. systems. Is that something that is a kind of important focus area for Rockwell?
Well, it's just natural that the complexity increases with the increasing number of different systems and different, let's say, hardware suppliers, right? It's clear that you're gonna you have different networks maybe and different interfaces, but I think it's also possible today, to manage those kind of things by using some open systems for secure networking. So that would be, for example, OPC UA. This is something that we see that a lot of startups are using, but also other companies, in order to get control of this topic. And then, of course, talking further, to the connection from the OT space to the IT space, there is devices, so-called edge gateway devices, that then connect this data that is collected from the shop floor to your cloud and to your IoT platform, right? There is also solutions available for that on different vendors. Of course, it's not necessary to send all the data that you generate on the shop floor up to your IoT platform or your cloud, because that would end up with some latency issues. So, and there is a huge amount of data created. So we also see more and more on the production floor that so-called edge devices are added directly to the machine. So that means those are devices that capture all the data generated by the sensors of the machine, and they pre-process the data. And that the big advantage here is that you don't need a data scientist to implement that. It can be fairly quick, right? You just add the edge device and you're more or less set to go. There is pre-configured templates for dashboards, and you quickly get insights into what is going on into your machine. And only the most relevant data is then basically sent up to the cloud, for more advanced dashboards and for more advanced analytics, etc. So I think this is some things that we see going on at the moment. And apart from that, in terms of interoperability, I mean, we as a company, we're more and more especially on the software side, we're developing into a vendor agnostic company. So for us, it doesn't matter, what different suppliers we work with. So we can connect to almost any source of data or source of information. And I think this is going to be, really key in moving forward. I mean, maybe in the future there will be, let's say, one common standard, and I already mentioned OPC UA as becoming, let's say, more and more important in the industry. But let's see how that at the end of the day evolves.
Absolutely. OPC UA is certainly something we pay quite a lot of attention to here for our audience at AMS. Maybe one last area. It's been raised a few times, but just to get a sense from the panel, the opportunities or the current versus opportunities in the market in terms of cobots and what we're seeing in automotive production, say right now, versus where they may see further use. Maybe there's a relatively lower use compared to some industries, but Laurent and so on, where do you see cobots and the role that cobots are playing in modular production, and where's the big opportunities?
Actually, we have some experience to work with cobot for the car like assembly line. Actually, for the inspection line, currently the cobot is one of the good benefit to work with the human directly. There are no pens and also working together, and it's quite safety. So that's why it's easy to work with the people. So now already some of the car makers already adapt to use the cobot in the like final inspection lines, so and also assembly lines there. So with the people, just so it's easy to work, and even they can reduce some of the workers, and also more efficient and very like simple working is by the cobot, and also some little bit like dangerous like working area is by cobot. So, and also very accurate and very stable and working, and also inspection point of view, they check right position. So now it's just starting, and also it's extended a lot of different applications nowadays. And also then also we support all of the like extended cobot range by our slide kit, lift kit. So this cobot has some looks like it's just one arm. Then they need more like a wider range to cover by cobot that they want. Is now already it's all of the demand is from the market. So it's Evelic side also we provide lift kit to lift up the cobot more than 1 meter, for example. And so slide kit it means like a transfer from A to B more than 3 meters. And also direct link to a system with cobot and software. So it's now it's really booming, and now it's starting to go that direction, and for the assembly line and inspections, by cobot.
Yes, because and if I can add up on what someone just mentioned, we have, I mean, if you visit an automotive plant, you will see that you still have a lot of, in the body in white, it's already a lot of robot with, closed cells and so on. But if you go at the end of the line, as mentioned by someone, like final inspection, quality and so on, this is where you have a lot of human, and where you have a lot of human, then you need the support from the cobots going forward. So, and what we see with the cobots is actually the same trend as what we have seen with the industrial robot, is that you need to extend the scope of use of the cobots. So you need to make sure that you can have a 7-axis that you can add to the cobots in order to bring your cobots from one place to another. So with the same cobot, you can move it as mentioned, or you can lift it up to a different position. So this is extending the use of the cobots in a final inspection line. And this clearly we see, and we had some discussion with numerous car makers. There is clearly a lot of work ongoing on in this particular area to have it. Also, we've seen that in the cobots part, in the link to the 3D printing as well. There are a lot of 3D printing now in the car industry. So we've seen some example now of use of the cobots in order to combine different 3D printers on the floor. So that's also another type of area. But the final inspection really was what we see going forward for the cobots in the automotive industry.
Christian, anything you'd add to that?
Yeah, I personally haven't had a lot of experience with cobots, but I think there is definitely space for those kind of solutions, maybe in smaller factories or smaller areas, or for applications that need to carry less weight, because I think in terms of accuracy, in terms of speed and other things, the traditional robots are the more superior solution. On the other hand, they're very flexible, right, and they are way easier to install, right. But I think the most critical thing, similar to AMRs, is really the point with the safety, right? So the safety approval is more complex, and there is also something where we can support with digital twin software to basically, you know, simulate and emulate the movements of those cobots to you know, support that safety approval process. So yeah.
Fantastic. Well, I think we're coming to the end. Maybe I can bring us out with a final question, just looking ahead. With your visions for modular, highly flexible production in the automotive industry, how will this develop over the next decade? What do you expect to see by 2030 that's different, further advanced than we're seeing today? I'll start with Evolik's team on that first. So Laurent, someone, just your vision for 2030.
I think from what we see, I mean, we discussed that along the past hour, but I think for us, you know, if you look at the projection and forecast about the electric vehicles proportion in the total scope of the vehicle, you can see that the speed and the magnitude of the change, probably enhanced by the COVID as well, is extremely fast. I think the number of non-electric vehicles in 2030 in Europe will be around 10 to 15%, extremely low. So this change of flexibility is just happening now and will continue to happen, because, you know, you have to build greenfield, you have to invest a lot in brownfield plant as well to upgrade them, and this will take a couple of years as well. So for me, I have a feeling it's maybe we should not say we are at the beginning of a journey, but I still think we are at the early phase of a journey from my viewpoint. So I see this flexibility as a topic for the next 10 years at least, if not more.
Absolutely.
Yeah, I just added more things about the electric vehicle. Anyway, now many car makers, they already announced they will go the electric vehicle. Yeah, so that's already they fixed their direction, and that means they need to invest. And during the investment, and they need to change the production line. That means they really want to go their future with a flexible system for their electric vehicle. That's why they are now really look at detail and checking and testing and working with us. So then it means that like the market for the flexible line will be bigger and bigger. At least until the end of 2030. Yeah.
Great, thank you, Sangwon. Can I, Christian? What about you? How do you see it over the next 10 years?
Yeah. So I believe it strongly depends on the final product, no matter whether it's EV or battery, and the purpose of the vehicle, quantity, whether you need a more regional or global presence, and also the need of being close to your end customer, right? So for me, modular does not necessarily mean sale-based. You know, a lot of people think about, okay, everything needs to be organized in sales and connected with HUVs or AMRs or whatsoever. And for me, it's also not just limited to the production floor and to the hardware. For me, the design and the operational software is equally important, or maybe it's even more critical in some case, right? So, honestly, I cannot remember a single car maker that is currently not trying to become more flexible. So it's been there for quite some time. And it doesn't matter whether we are looking at startups or the traditional car makers. So what I see is that this transformation is already happening right now, and that there is, of course, still a lot of work ahead of us, you know, to further improve on that area. I mean, EV technology is also still evolving, so I'm sure there will be other challenges and innovations by 2030. So it's a never-ending innovation process, I guess, which is great, and we're of course happy to support clients in this journey. So
yes, well, when we're fitting solid state batteries and hydrogen fuel cell to the line alongside the other an autonomous vehicle. So I'm sure there, as you say, there'll be no shortage of varieties driving the need for flexibility. And in fact, one of our audience members also raised a point, as you just said, Christian, that it's that desire, that need, requirement has long been there. The comment was actually that, you know, the person who worked for Jaguar from the late 80s with body in white was being phased from manual to robotic lines. The volumes did not justify then dedicated lines, so flexible tooling for short and long wheelbase sedan doors and shells was a no-brainer. And later on, the convertible and coupe line did the same. Similarly, when we went modular on the final assembly to improve space and quality, but mostly manual plus automation rather than robotization. Volume has a huge influence, and gigafactories versus microfactory now highlight this, both Toyota or Arrival. So just kind of, I think, speaking along the lines of what we've just been hearing. Finally, just to kind of close, I mean, Nick, any parting thoughts from your side as we look ahead? I think we've got our work cut out for us over the coming years.
Well, I mean, I agree with the panel, and they're far more pragmatic, perhaps, probably than I am, because they're dealing with it on a daily basis. But I mean, in terms of the future of this kind of flexibility, with the things we've discussed today, I would think, I don't know how far in the future, but the aim might be to make the entire factory flexible in an integrated way, not just in individual operations throughout the factory, but the idea of this industrial cloud, observing everything that's going on. So that we talked about flexibility in terms of volume and tasks within individual cells and individual parts. But if the entire factory is being managed in a way from beginning to end, then it's adapting each section depending on what volume is coming through that factory in terms of materials, supply, models, platforms, whatever they might be. And as we mentioned there, that's an evolving thing. The need to be able to cope with that might need the fact that you need this whole factory integration and this whole visibility from one end of the process to the other, and then the flexibility is applied to the various cells. So I think the idea with the digital twins, etc., is something again which is just going to support and enhance that. And then down to from the software to the hardware, we're seeing that, you know, software can be as clever as you like, but you need the hardware to be able to do that, and vice versa. So this sort of combination, and I think the greater, we touched upon this, the greater sort of collaboration between the equipment and tier suppliers and the car makers themselves will become much more close-knit and will facilitate that as we go further forward. How fast that will happen, I don't know. I'm not dealing with these clients on a daily basis, so I'm sure the guys have got some observations on that, but that's probably kind of where I see flexibility going in the longer term, or hopefully does.
Okay, well, that's a good point at which we'll leave it. I want to thank our experts, Christian Leitner, Laurent Sanchez, Sungwon Lee, and Nick Holt for joining us today, spending the last hour, 70 minutes going into some detail on this. We've just scratched the surface. As always, there's a whole lot more we could discuss, and I will discuss, and I look forward to keeping up with all of you along the way. So thanks again to all of you.
Thank you.
Okay, thank you.
So just to part before we go to our audience, if you're in Germany and you're interested in Hanover at the beginning of June for the around the time of the fair, Automobile Production Congress, which is a sister company to Automotive Manufacturing Solutions, there's a great event going on, which we certainly would encourage you to check out, featuring a number of board members from production from a number of OEMs like Porsche and Mercedes-Benz, and leaders from BMW Group. Definitely something worth checking out, looking at a lot of the kind of digitalization, sustainability, electrification topics in manufacturing. We've got a special code here for our audience as well. As a promo, the link is dropped into the chat right now. You can get 20% off of the ticket there. So do check it out. We really encourage you. We work closely with those partners as well for our sister publication, and there's an amazing event that they're putting on. Thanks again to our sponsors today, Evolix and Rockwell Automation. Do check out more information on both of those companies, and any information that you'd like or connections you'd like. You know, feel free to reach out to us at AMS, or indeed directly to the panelists you've heard from. Also want to encourage you to check out the latest digital edition of Automotive Manufacturing Solutions. Lots of great insight on flexibility in manufacturing, on electrification, on investments that are happening, including at Volvo Cars, but also looking at things that Magna is doing, for example, with electric pickup. So lots of great stuff. There's a link coming your way as well. And finally, a reminder, in 3 weeks' time to join us at the AMS Automotive Evolution Summit. We've got so much great stuff going on then, including another panel on flexible automation, where we'll go into more detail, pick up on some of the exact topics we were talking about today, look in more depth. But as mentioned earlier, we're talking with a range of leaders across OEMs, suppliers, equipment providers, and technology innovators in this space. And we'd really love to see you there. So we shared earlier the code to get 50% off. It's free if you're an OEM or tier supplier. So do consider joining us. And keep up with us along the way. The Evolution live stream series, along with our events, are things happening every month. So tune in. We've got a show coming up after the event, end of June, on connected manufacturing. So watch this space for more detail on that discussion. Get in touch. You can get in touch with me if you're interested. My colleague Amos Sarek, who's helping to produce these events, and of course Nick Holt as well, our editor. Always wanted to hear from you on any of your ideas or thoughts. Want to thank you for joining us today. It's really been my pleasure to host it, and can't wait to see you again for the next one. So thanks again, everyone, and wish you a great rest of the week and weekend to come.